As the chairman has already introduced myself. I'm going to speak on Lantana-induced volatile compounds, asking the question of whether they attract or they repel the Falconia intermedia. I'm not going to dwell much on Lantana, as Unat has already mentioned that most of us, they know what is happening with Lantana. We know that it has invaded 7 provinces in the country. And in 2001, 5 sites in the Eastern Cape where the Falconia intermedia, which is one of the control agents, were released. In 5 sites, 3 are the coastal sites, East London, Port Alfred and Whitney Farm, and 2 are inland sites, which are near Grahamstown, which is the Lyndhurst and Heather Glen. What happened is that the Falconia intermedia only managed to establish in 2 of these sites, which is in East London and Whitney Farm. But last year we managed to figure out, to see that Falconia intermedia has grown, like it has just like moved to the side of Port Alfred and causing so much damage. Even though that we see that the insect is feeding on the plant, but the plant still persists to move and disperse and invade to new areas. As Unat has said that there are induced responses that you see after the feeding by this insect. He has mentioned that there are leaf trichomes and induced leaf toughness, which means that the insect is unable to feed or move on the plant when these traits are induced. He also discovered that there are induced volatile compounds that the plant increases. However, it is not known yet as to what is the effect of these induced volatile chemicals, which brings us to the objective of my study. That's what I'll be doing, to check exactly what is the effect of these induced volatile chemicals to the insect itself. So far, this is how we did it. We have 5 varieties, where we keep some as undamaged, and the other 5, we expose them to the feeding of Falconia intermedia. After that, we then run olfactometry trials. What we're doing with that, the insect will give an insect an opportunity to make a choice of which odor source it chooses. Here we have a white tube set up. At the back there, we have a pump which is pumping the air to these 2 conical flasks, where we have a charcoal which purifies the air, and then air moves to the distilled water, where it gets humidified. It then moves to the flow meters. In flow meters, the airflow gets regulated. It then moves, the air moves to 2 of these 2 conical flasks, where we put our treatments, our different treatments. It then moves to, we then introduce an insect to this white tube at this end. This first line, we take it as a starting line. When the insect moves, passes this first line, we start counting. It then moves and chooses whichever arm it prefers. After passing one of these lines, we take that as a choice, but we consider the time that it spends on each arm. For us, we take a minute for an insect for us to record which choice it has made. And also, if it happens that it doesn't pass that first starting line, 5 minutes passes, we take that as a no choice. So far, for our preliminary results, we've managed to find that there is a significant association between undamaged leaves and the insect, meaning that the insects, they prefer more the undamaged plants. That could explain why the insect, after feeding on the plant, it will move to new plants. Coming to a conclusion that these induced volatile compounds, they have a repelling effect to this Falconia intermedia. Moving forward, we're going to perform hydrodistillation, where we'll be gathering the essential oils of all these varieties and these 2 treatments, which they feed undamaged and damaged, and get these compounds to be identified using the gas chromatography, mass spectrometry. And after getting those